The differential scanning calorimeter is a machine that uses a thermal analytical technique to calculate the heat changes that occur in a sample and reference. This change is the amount of heat needed to raise the temperature of the sample and reference and is measured as a function of temperature. For safety and precaution, try not to breathe into the ports. This introduces an unwanted element of moisture into the experiment. Be sure to avoid touching the tube that runs from the chiller to the DSC sample port. Depending on which tests are running, it can be either extremely hot or ice cold.
When setting up the DSC, remove the lids of the sample port with tweezers and check to see if the port is empty. Make sure the chiller is running to control the conditions of the port. Feel the outside of the sample port to see if it is on. Warmth denotes the machine is on. Log into the computer as lab user to begin the experiment.
Prior to the actual run, do 2 dry runs of the sample port of the DSC according to the user manual. Calibrate the instrument to achieve accurate readings according to the manual. The precision of the instrument is based off of how accurate the calibration is. Before starting the experiment, decide on the type of pan to be used. For our experiment, we used aluminum pans.
It is important to make sure that when inserting the pans into the sample port, you are careful to place the reference pan on the back thermopile and the sample pan on the front.
Choo!
And welcome to Prescott 301. We'll be showing you how to use the DSE. In preparing the DSE, you need to make sure the argon is on and connect you to the DSE itself, running at approximately 30 millimeters of mercury. You also need to make sure everything is on and operational. The DSE needs to be on by the green light and ready by the yellow light. The chiller also needs to be on to keep the DSE steady. The computer needs to be on for data analysis and logged into as a lab user. The DSE has 3 lids. There's also a reference pan in the back and a sample pan in the front. The tube which extends from the DSE is not to be touched because at any given point it can be very hot or very cold.
After logging on to the computer as a lab user, click on TA Advantage Control. After pulling up TA Advantage Control, make sure that the DSC is being run. Under the Summary tab, type in the sample name, sample size, comment, the data file that it will be saved in, and make sure that the test is custom. After typing in all the information under the Summary tab, click on the Procedure tab. Type notes for the desired experiment, and then click on Editor. Drag and drop the desired procedures to the notepad on the left. After specifying all the information for the procedure, click Apply, and then click the green arrow in the upper left-hand corner. This procedure will take an hour and a half of waiting. After the procedure is complete, there will be checks beside Run 1 in the upper left-hand corner. The data from the procedure will be on a graph to the right.
After the run is finished, the resulting graph illustrates key features about the sample, including the heat of fusion, the heat capacity, and Q dot. The area inside the curve directly relates to the heat in the substance, or the heat of fusion. The slope of the line after the curve represents the heat capacity. A straight line reflects a constant heat capacity. Q dot can be calculated by multiplying the mass flow rate by the heat capacity and the change in temperature with respect to time.
Who's going to be doing this?
I am actually.
Yes.